Welcome to The Explainer. Today, we're diving into what is, no joke, the biggest shift on the factory floor since the assembly line itself. So, get those old images of loud, clunky, greasy machinery out of your head. We are talking about smart factories, where data, AI, and connectivity are completely rewriting the rules of manufacturing. But before we get into the how, let's start with a number, 51.2%. Any guesses? Well, in a real-world bakery that went fully digital, this is how much they cut the time their products spent just waiting around between production steps. Think about that. They slashed that dead time by more than half. That is the kind of wild efficiency we're talking about here. So, how on earth are they getting these kinds of results? Well, it really comes down to a few key technologies that are making these places faster, way smarter, and just radically more efficient. Let's break down exactly how they pull it off. Okay, so at the very heart of this revolution is a concept called the digital twin. I want you to imagine a perfect, live computer simulation of a machine out on the factory floor. I mean, every single gear, every sensor, every process, all of it is mirrored in real time inside a computer. This virtual copy lets companies test, monitor, and fine-tune the real machine without ever having to shut it down or risk breaking it. And this virtual world creates some very real-world results. When you combine these digital twins with all the data pouring in from the industrial Internet of Things, that whole network of sensors on the factory floor, the gains are just staggering. You see production cycle times drop by 5 to 8%, energy use goes down, and you get a huge jump in something called overall equipment effectiveness, or OEE. That's basically the gold standard for measuring pure productivity. All that data leads us to another total game changer, predictive maintenance. So instead of the old way, waiting for a critical machine to break down and bring the entire line to a screeching halt, smart factories use AI to see the future. It can predict when a part is about to fail. This lets them schedule repairs proactively, turning what would have been costly, chaotic downtime into planned, efficient uptime. And the numbers show this works brilliantly. Prediction accuracy, that's a metric called AUROC. It jumps from a pretty good 0.78 to an incredible 0.94. But maybe even more important, the rate of false alarms, the system crying wolf, it drops by more than half. That means the maintenance teams can actually trust the alerts and act on them with confidence. And we're not talking about small-scale stuff. This operates at an absolutely massive scale. One test, using data from NASA, of all places, showed these systems chewing through over 1 million data events every single minute, all while holding on to over 90% accuracy and responding in under a second. This isn't some science fair project. This is ready for prime time. So what's the ultimate payoff for all this data, all this prediction? It's getting closer and closer to the holy grail of manufacturing, making perfect products every single time. Real-time scanning and AI quality control can spot microscopic errors instantly, pushing factories toward that ultimate ideal of zero-defect production. Of course, all this incredible technology brings up a huge question. What happens to the people, the actual humans who work in these factories? And that brings us to the critical human element in this whole transformation. Let's just ask it directly, because it's the question on everyone's mind, right? With machines that can predict their own futures and optimize themselves, is there even any room left for human workers? Well, the answer, according to this emerging idea called Industry 5.0, is a pretty clear no. The goal here isn't to replace humans, but to augment their skills. It's all about creating a partnership where human creativity and judgment are supercharged by the raw analytical power of AI. The result is better, faster, and much safer work. So far from killing jobs, this revolution is actually creating entirely new career paths. Companies are desperate for digital twin engineers who can build and maintain these virtual models, MLOps practitioners to manage all the AI systems, and edge AI specialists who can run these super complex algorithms right there on the factory floor. But let's be real, this whole transformation isn't as simple as flipping a switch. I mean, if it were easy, every factory on the planet would already be smart. The truth is, making this digital leap comes with some serious, real-world challenges. Companies are basically staring down 4 major hurdles. First off, the upfront cost can be enormous. Second, trying to get brand new systems to talk to decades-old equipment is a huge technical puzzle. Third, there's a major shortage of people who actually have these new digital skills. And finally, connecting everything to the internet opens up a whole can of worms with cybersecurity. Yeah, that integration problem, it's a really big one. A lot of factories are what you'd call brownfield sites, meaning they're full of old but still reliable machinery that was built long before the internet was a thing. Trying to make that legacy gear talk to a modern, interconnected platform is, well, it's complicated and it's expensive. And connecting everything creates another massive headache, which this quote just nails perfectly. When you connect your factory, it's like you've just installed 1,000 new doors and windows. Every single one of those sensors is now a potential way in for a hacker. Your attack surface just explodes, and every single one of those new connections needs its own lock. So to fight this, you can't just have one lock on the front door. Security has to be this deep, layered defense, just like you see here. It starts with protecting the actual physical machines, then you add layers of AI that are constantly hunting for threats. You have to design systems that can bounce back from an attack, and even use automation to spot weird behavior and lop things down instantly. It's a whole strategy for a very complex problem. So you've got these incredible benefits on one side, and these massive challenges on the other. How do we move forward? How do we take these amazing pilot projects and scale them up into an industry-wide transformation? Well, it's going to take a clear, strategic roadmap. One of the most important first steps is just creating a common language. Seriously, think of it like agreeing that all electrical plugs should fit into all outlets. Standards, like this one called ISO 23247, define how all these different systems should communicate. This ensures that tech from company A can actually work with tech from company B, which is absolutely essential if you want to build a connected industry. And you gotta remember, success here isn't just about buying the fanciest new tech. It's about strategy. The companies that are really winning at this are anchoring their digital investments in proven methods, like lean manufacturing. They make sure every dollar they spend on tech can be justified with what they call CFO credible returns, which is just a fancy way of saying real, measurable profits that the finance department can believe in. Governments can also play a huge part here. Smart policies, like helping some of the really influential companies invest in this technology, can create this powerful ripple effect. When the biggest players in an industry start to modernize, it basically forces their entire supply chain to get on board, which speeds up the change for absolutely everyone. So we're left with this final thought. The technology to build the factory of the future, it's not science fiction. It exists right now. The code has been written, the sensors have been built. The real question is no longer, can we do this? But rather, do we have the strategy, the skills, and the vision to actually manage what we've built? The revolution is already here. The challenge now is to lead it.